Alright, so this is going to be the third and final part to homework 2. On the previous one, we ended on just plotting all the data points from this, and yeah. So to start this one, we are going to be modeling the Antoine equation, and we are going to be using A, B, C, and capital T as the variables, and then right here is the equation. All these right here are just the guesses. You need guesses for A, B, and C. So the guess for A was 20, the guess for B was 2000, the guess for C was 0. And then we're going to take all these guesses, plot them in an array, and just call it x sub 0. Right here, we are going to be defining the square error function. In order to do this, we're going to be using x, the temperature, and then the log of the pressures. Right here, model PV is going to be our new model that we create. We will be using index 0, 1, and 2 for the x's and the temperature. And right here is where we're going to be calculating the square error. We're going to use Jack's NumPy, and then we're going to use all the data from the new model subtracted by the log of the pressures. So just take the log of all of these, which we calculated earlier, and then we're going to square that value. That gives us our square error. And then to get our result, we're going to be using the minimize function, which I showed in part 2. We're going to import, or from SciPy optimize, we import minimize. And that's where that comes into play right here. We'll be minimizing the square error function. Right here is just your initial conditions. The arguments are going to be temperature and the log of the pressure. This right here is just, you can set your tolerance. And then this is the part I didn't really know that you needed. Every time I would try to run the function without it, or run this without it, I'd get a lot of zeros down here, and I knew that couldn't be right, so I had to do some research, and I found that Nelder-Mead does work for it. And you can see it comes up true here. All these numbers are much better than just a bunch of zeros. And so down here, this is the final temperature. I'm using linspace from the beginning to the end in increments of 100 to get the final temperature. And then this is where I just create the new plot. So my x is equal to the final temperature, and then the y is equal to all the data that we just got from right here, and then the final temperature here. And then we use mode lines in order to get this instead of the little dots. Line width, pretty self-explanatory, just the width of this line. And then once again, the name over here was Antoine line of fit, and then fig.show will pull up the entire plot for you. And so yeah, that's it. That's all for my part 3.